with the, this won't help anybody in the video, but I'll do it with a pencil just to kind of, if I took these two pencils and if I, it's two that match, these two pencils, and if as I opened it, a line was formed between them. So like imagine, you know, as I move it, a line is being created. I'm drawing a line. So as I move that, that line stays the same distance from the center, right? Because this is always going to be the same length. So eventually as I go, I get to that point. Well, what angle is that? If I tell you it's perpendicular. 90. Well, I just create, and it 90 is 1/4 of a full way around. Well, that's 1/4 of a circle. It's a quarter of a circle. They match up. Like if I keep going, I go halfway around. What's that angle? Well, 180. Half of a circle is 180. The angle will always match up if it's coming out of the center of the circle. That's basically how you create a circle. So again, central angle will always match its arc's measure. And in degrees, typically the way you're going to measure a central angle, you can measure it in radians, which was another thing. I didn't put that on here. That was another thing you've already been tested on. So a lot of you are going to need to retake that. So the same concept of the central angle, the percentage of the central angle is the same as the percentage of the circle. So that's why the first step was, let me go over this. That's why the first step was, what percentage of the circle are we talking about? And you just had to figure out which units of measure do I use to figure that out. If it was in degrees, you divide it by 360. If it was in radians, like the part they gave you was in radians, then you divide it by a full circle in radians, which was what? 2 pi. 2 pi radians. So we divided by 2 pi. But all of it's based on that concept right there. All of those things. Now, this is kind of where you were going, Isaiah. Well, actually, I'm going to show you why this is true, too. I don't think I did in this class. So here's an inscribed angle. What's the definition of inscribed? How's it different than the first picture? Yeah, it's not coming out of the center, right? We said the vertex of an inscribed angle is on the circle. It's technically the same point as the point. They share a point, really. It's not really on it, but so if we have an angle that looks like that, we said that the formula was that the arc is twice the angle, or the angle is half of the arc. So we just divide the 42 by 2 to get that. Again, we did all kinds of problems with this. And this actually came up again in this chapter, which I think one of the problems on the back, actually maybe even one of the ones on the front. Yeah, one of the ones on the front from the current lesson is that same concept. If I have a vertex on the circle, the angle is half of the arc. Really quickly, again, if you don't get this, don't worry about it. I'm going to show you why that's the case, or like a way to maybe help you memorize this one. If I draw that in, what I create, it's a triangle, right? What's true about all triangles? The measure of the interior angles, that angle plus that angle plus that angle adds up to 180. Right? We know that. Now let's think about what percentage of the circle the arcs take up for that triangle. Again, if you don't totally get this, don't worry about it. You want to write it down, you can. I'm not even worried about writing down. So, actually, no, that's probably not good. Let me use just pins for it. So I've got this arc that is labeled X, right? I'm sorry, this angle. That angle goes out to there. So my arc is between those 2 points. That's the arc that matches up with the angle X, right? Done that. I hope you get that point. So this angle matches that arc. You're not seeing, we did a whole lesson where I showed you how to find arcs from angles and angles from arcs. You're not getting that. Again, you're going to really struggle. So now let's go to this one over here. Actually, let's color code it. So that angle was in blue and the arc is in blue. So now let's go to this angle. We'll make this angle green. Well, again, if I take that angle and I go all the way out, I just trace the angle basically. This is the arc for that angle. So there's the arc for that angle. And then as the last, we'll do the last one in yellow. That should definitely show up. So here's my last angle. Do it in yellow. Well, I trace that one out. So that angle goes from here to here, from there to there. So here are its endpoints. I'm trying to not cover up, but they're all the same endpoints. I'm trying not to cover it up. So the arc associated with that is that arc. How much of the circle did I just do as far as arcs go? How much of the circle did I cover with those three arcs? Whole circle, right? Every single part of the circle is covered. I covered from here with the blue, then with the green, then with the yellow. I covered the entire circle when I was using these angles and their arcs that are associated. How many degrees in a circle? So I know the arcs are 360, right? How many total degrees in a triangle? So the degrees of the angles are half of their arcs for an inscribed angle. Again, that's not technically a proof, but that might help you remember it potentially. That's why we can take half of an inscribed angle, half of the arc to find the angle, or if we're going the other way, we multiply the angle by 2. It's because basically if we drew in a triangle, an inscribed triangle, we know that's 180, and it will cover the entire circle if we trace the arcs for that triangle. You can go ahead and go now, Chance. Next problem. This is from. Oh, let me give you a pass. Oh, I just had one. This is from this lesson that we're on. So this is your quiz Monday. This is the first one, I think, that's like this we've already quizzed on. I just wanted to go back over it. What's happening in that circle? What's the thing I said look for? There's no perpendicular symbols or 90 degrees, so we can't say perpendicular. You said perpendicular. Oh, I know what you're talking about. I know what you're talking about. Yeah. That doesn't actually come into play, but yes, that's in there. You don't, I'll say it. What's happening in there? I think I know. Well, that's basic. Even like just visually, what's going on? No. What? Ignore all the numbers. 2 lines are crossing. Where are they crossing? Inside the circle. That's your trigger. 2 lines that cross inside the circle. That's when you use what we're about to do. One of the things. There's other things. I mean, there will be other problems where you have 2 lines crossing inside a circle and you do other things. But if you see 2 lines that cross inside a circle, this math will work. And again, you may not use it because you may be figuring something else out. But if I need to know, oh shoot, I apparently erased those lines. So I think it's on your sheet. So that's 27. You would need to know that 27 has to be shown. So if I know that angle is 27, now we're getting what you said. What? No, vertical. If I know that's 27, what else do I know? Ooh, get it? Yeah, the angle across from that is 27. So that's the first thing. Again, so that's, again, just do what you know. Hopefully you know some stuff. So if that's 27, that one's also 27. So I know those 2 angles are 27 degrees. Hopefully you can see it. If not, you're right. Now I know one arc is 31 degrees, and they want me to find the other arc. And there's not a like direct relationship where I can just say, oh, I just multiplied 27 times 2, or it's the same as 27. Because this 27-degree angle could move. I mean, that 27, if I took these lines and I moved them back and forth, it's going to change the length of the arcs. The arcs are going to change. The angle could still be 27, but if I move these lines in, they're going to have to be longer to hit the circle, which means the arc's going to be a little bit bigger. So with that in mind, this is again just there is a proof behind it. Am I going to do this? I'm not going to worry about it. Maybe if we have some review time, maybe we'll come back to it, because I've heard, and this is just completely rumors, who knows if it's true, or there's a lot of circle stuff on the EOC. So if we get time and we can review circles, maybe we'll go over like some more conceptual stuff of why things are true. But here's the map. If I have two lines that cross inside the circle, if I am dealing, so look at your other side of your page that has all the writing on it. The right side, I think, maybe has a picture like that. Is it the right side? Oh, they both, yeah, I'm sorry, they both do. The left side, though, is about arcs and angles. That's right. So if you notice the left side, it says arcs and angles. The right side, it says lengths, I think. But it does have that same picture twice. So you're gonna, for that formula where they cross inside, this is the formula I've given you. I take the measure of the arcs and I add them together. So that's where I did arc 1 plus arc 2 when we did this in class. Should have that written down somewhere. So I do arc 1 plus arc 2, and I divide them by 2. And that gives me the measure of the angle, which is the same, like both these angles are the same. So it'll really give me the measure of both angles, but we just say the measured angle. That was the formula we did. I want you now, if you didn't have that, first of all, write that formula down under the picture on the left-hand side. I think it's the very top picture on the left-hand side on the page with all the writing. That's the formula that should have gone with that, under where it says formulas. Talking about which one up here or which one up here. So this formula here goes to the page with all the writing on it. The other side, basically, top left. That picture, art where it says arcs and angles. Oh, look at that formula where you write it under where it says formula. You have so try to solve now that you know if you didn't already do it. I'll do this a little smaller, but hopefully you can do math. So if you want to check your work, that should have been your first step, the equation right there. Go over here. So we, like when we did a lot of the practice problems in class, the examples, well, that's the formula, and I'm just plugging numbers into that formula. We saw for the angle, I think, in the example that we did. It's still the same formula. You just have to understand, well, if they give you the angle, so if they give me that, then I need to plug that in. You don't always just put the numbers here and divide by 2. That's why I put this on the paper. And you should, if you practice the problems that I assign, you'll get some where you have to do this also. But we haven't been great on practicing, it doesn't seem like, because I'm putting some of the exact same questions on quizzes and we have no idea how to do them. It tells me you're not practicing. Or you're not getting help when you don't know how to do it. If you are trying to practice, you're not getting help. So now if you didn't get that far, that's the equation. You can try to solve that. Well, hopefully you can solve that for x. There's a couple different ways to it. Raise your hand if you're 100% positive you know how to solve that out. How did you do it? Don't tell me an answer yet. How did you do it? Tell me the first step. All right, so actually that would be your first step anyway, actually. Did you change anything in it or did you do it the way it looks there? Okay. So we'll come back to that. Anybody do it a different way where they made a change to what we're looking at there? I'm telling you, if you get this next thing down, that's the one I was getting to. If you understand, when I see a fraction on one side and either a fraction on the other side or just a number, because I can change that number into a fraction, that way works so much easier on some types of problems. This one is not that difficult to do it the normal algebra way. But if you just remember that you can do this, make that a fraction on the left. Now, you can't do it if you have a fraction plus something else. Like it's got to just be one fraction and one fraction. But cross multiplying, when you have a lot of variables in a problem, which sometimes you have all variables in a problem, like the EOC, they don't always give you numbers because they just want you to know the concept. So they just put a bunch of variables in there, and then you can't just calculate. You gotta understand. So sometimes cross multiplying and proportions works well in that. But if you take those two things multiplied together, those two things multiplied together, the 27 would be on the top, the 2 is on the bottom. Then you set them equal. I'm gonna go back to yellow just so it'll stand out. Actually, that's pretty good there. So 27 times 2 is 54. I set that equal. I do not make another fraction with it. A lot of people are still trying to make another fraction at a point. X plus 31 times 1 is just x plus 31. And now to solve for x, you just subtract 31 from both sides. So the measure, and what did we just solve for? Hey, that's what I'm going to call on. What did we just solve for, Shade? Which is the what? Not the number, not the answer. What is x? X is what? Like representing what part of that figure? Well, there's a word for it. I want you to say the word. Not the angle. These are the angles in here. So what is x? Oh, what is it? It's the arc. Written right here. Arc 1 plus arc 2. So this plus this divided by 2 equaled the measure of either angle. Like you're only solving for one of the angles. This 27, I was just kind of reviewing old concepts, but you're solving for one angle. It just so happens because they're vertical angles, it's the same measure in both angles. So when we saw, so what did we get? I forget. What was it? 54 subtract 31, so 23. So 23 was the measure of this arc right here. So arc, I didn't put letters on it, but that arc right there, okay. That arc right there is 23 degrees. So that is this quiz on Monday. This one's also this Monday. Actually, both of these are this Monday. Is anybody still writing that stuff up there? About to get rid of all of it. It's recorded, so I'll post it hopefully today at lunch. If not, probably tomorrow during my planning. All right, so here's another picture that you had. This was from this I think this might have also been in another lesson. This picture's very similar to that. So you have a couple times when this might visually show up, but in this particular lesson, it says, well, I know that angle ABC. So it's telling us we're talking about angles. I know that based on the symbol, angle ABC. So I'm still in yellow, so this will work. That's this angle. That is angle ABC. I'm not going to draw anything inside of it, but we'd be, well, I'll do it and get rid of it. So that angle right there, that's angle ABC. Give me a guess. What's the measure of that angle? You know what it is. They give me a guess. I forgot that I already written it up there. I was thinking that's what we were solving for. So don't forget though, I would say at this stage of geometry, most figures are probably going to kind of be the same. So if you look at it and you're like, okay, I know that's a little less than 90. I know it's around a half 90. I know. Oh, is it not live? No. Oh. I normally am pretty good about that, but yeah. Actually, because people have been knocking on it, so that's why I thought it was locked.
What's that?
They've been knocking on it, so I thought it was locked. Like they knocked. I've been letting people in. Yeah, that's fine.
Sorry.
Oh no, that's my fault. Thank you. Yeah, like I told you. Oh, what was it? I told you they're a big deal, right? It's a big deal right now. That and kids being in other class. She's in here because she's in driver's ed, so that's fine. But like if you've been going to other classes and getting passes, or even coming to do a retake during other classes, we just got teachers got talking to yesterday by the principal and a guy from the district, like a higher up guy from the district, saying, "Do not do those things." So you may find your teachers are going to crack down on that stuff. So and you just
don't let students in the wings or anything
yes,
like that after the bell
you've been
rings,
doing that.
because you're gonna get in trouble.
Yeah, if you've been getting away with stuff or getting food, like picking up food, like from working around the fact that you're not supposed to get food brought to you, there's gonna start being some consequences. Again, how long that'll last, we'll see. But for right now, you better be careful. Just don't do anything right now. We had a whole meeting yesterday. Pretty much the whole meeting was about. All right, so now that we know that measure of that angle is 75. Huh. I had a pen. I don't need it. Drop it. So, 75 degrees is the measure of that yellow angle. What sort of kind of angle does that remind you of? Give you hints. Where's the vertex of this angle? On the circle, right? What other angle had a vertex on the circle? Somebody said number two. Number two, but inscribed angle. What was the rule up here? What's that rule to find the angle or the arc? Arc is 2 times or angle is half, right? It's the same rule here. So again, that one I don't think should be as tricky, because if you just say, well, it's not technically an inscribed angle because the whole angle is not inside, but I know it has the same rule because it's on the circle. The vertex is on the circle, and that is the case. The angle is half of the arc. So if I know this is the arc, I know what the angle is. What do I do to find the arc? Arc AB. Twice the angle. If I know the angle is 75, 75 times 2 gives me. So that one, that's kind of why I did the inscribe, like this whole review piece, because those two go together. So last one. Yeah, I think the last one. I mean, this one down here is a very difficult problem that I'll show you. I expect that won't be on your quiz for me. EOC might have some stuff like that. So we have a completely different situation. Still have two lines. And pictures can be different. Like, don't think the pictures are gonna be exactly like these pictures. I would need so here's the key. This is a tangent. Right? That's a oh shoot. Yeah, we gotta review something else. I gotta speed up. Forgot one piece. So that is a tangent line, by the way. Remember, a tangent just barely touches the circle. It technically goes through one single point of the circle. It doesn't go through the circle, it goes through like in the middle of it. It touches a point on the circle, which is why we can say that point is the vertex is on the circle. These are called secants because they go through the circle and the end point is outside the circle. What is this called? What's that? When it doesn't go outside the circle. That was a chord, remember? We'll get to that in a second. I got a review piece on that too. All right, so here's your next quick note. When the lines cross, because technically this is the same as them crossing. Like we could think of them just kind of extending out. Just because they don't in our picture doesn't mean that wouldn't have crossed if we kept resitting them. So when they cross outside the circle, so not like the one where they crossed inside that we did earlier, but it's still similar math. We're going to still have an equation that's close to that other equation. They cross inside, what was the equation for the arcs and the angle? We added them together and divided by 2, right? This is almost the same equation. Let's go back to yellow. I think yellow shows up here. More room down here. Not really. Oh, wait, hold on. Oh, there we go. Yeah. So in this particular equation, it's arc 1 still. Actually, let's make it different. We changed it, I remember. It's the big arc. Oh, forgot to change the color. It's the big arc. But instead of plus the other arc, it's subtract the little arc. So we're doing kind of the same thing, we're just subtracting. Big arc, subtract little arc, and then we still divide by 2. So if I know this is 41 degrees, I know this little one here, that arc right there, 19 degrees. I just plug them in to find the angle, and then divide by 2 to find it. So if I want to know angle AEB, plug those in, divide by 2, and that's the measurement. And you can, again, you can sort of rely on it being a scale. That's a really skinny angle. I mean, that angle, if 45, if 90 was here, 45 was half of that, that's probably less than half of 45. So it's going to be way down like 15 to 20 degrees of that. So when you figure it out, you should get numbers that kind of match. Figure it out. Was it 11? Was it that low? Oh, wow, that's really low. Say it again. So again, 41, subtract 19, 22, and then 22 divided by 11. The little arc. Oh, I don't know why I didn't mean to do that. Hold up. Well, hold that thought. I don't know why I put a line in there. But actually, here, let's do this. There. So the color coordinate. There. Little arc, big arc. Yeah, it was 11. Right. Again, it's easy when you sit here and you say, oh, yeah, I just got to plug those numbers in. Hard part is going to be when you see all these different circles on Monday, you have to know which formula goes with which concept goes with which. You got to put some time in Sunday.
So
Oh, well, actually, I didn't even finish. I'm glad you said that. This finds the measure of the angle. So again, we found the measure of angle AEB, which is this little tiny angle. That's why it's so low. Look how skinny that angle is. Why it's such a low number. This angle right here. Here, so that 11 degrees, if you trace the letters, that's the angle we're talking about. This little angle right here is 11 degrees. I'm gonna have to fly through the next part. That was the more important stuff. This other stuff you just have to memorize. When we're figuring out lengths of segments, there were 3 theorems. So now go to page, was it? Oh crap, I gotta do this. Shoot. All right, we're gonna have to go fast. So you're gonna have some stuff to do on your own. What are those things there? If that is says circumscribed, or it could say the circle is inscribed, the circle is inside, the polygon is circumscribed. What do I have then? We quickly went over this, but I just saw it on the quiz yesterday. What do we have there? A bunch of what? I'm hearing different things. Say first chance. So what did you say, Isaiah? So it is going to be about length, and it's about lengths of tangent lines, tangent segments. These lines are all tangent. So when it says either circumscribed or inscribed, they're telling you that so you know all these lines are tangents. They are only touching the circle at one point. We learned a theorem about, and this was on your last quiz, but it comes up again in this lesson. We learned a theorem about the 2 tangent lines to a circle if they intersect outside the circle. What was true about them? Say it again. That line is congruent to that. Every time you have a point outside the circle and you draw in 2 tangents, those 2 tangents are congruent. That is congruent to that. That is congruent to that. That is congruent to that. So it looks like a figure. Like it looks like a shape, and that people freak out. They're like, I don't know how to find the perimeter of that. Don't think of it as a shape. It's a bunch of tangents coming from a point outside the circle, which just means all those tangents are congruent. So if that is 3, that's 3. If that's 4, that's 4. If that's 1, that's 1. If that's 6, that's 6. Now you have all the pieces, all the segments. You just add all of them up. That's the definition of perimeter. You just add every single number up. 6 plus 1 means this side is 7. Well, 1 plus 4 means this side is 5. 6 plus 3 means this side is 9. 3 plus 4 means that side is 7. So if I now add all these numbers up, that side is 7, that side is 5, that side is 7, that side is 9. That's the perimeter. Oh, I didn't even add up. 14. Yeah, 14 plus 14. What are the odds? I think that happened. That's just a coincidence. That won't always happen. Quick review, some other stuff that we have done. What's true in this? We don't know that. Would that have to be true? You know, that's a good question. I don't know if that has to be true or not. Because it's not coming from the center. So even if they are perpendicular, they might have to be, but that's not really. So what's true? What are those lines called? They are chords, right? If chords are congruent, what else is true? That's the big one right there. So if you know those chords are congruent, the arcs are congruent. Here is where I was going with what you were saying. If this is a diameter, and if I know that happens, what's the only way that can happen? Well, I'm telling you they're congruent. What's the only way I can make 2 congruent lines by, yeah, it's a bisector, but what has to be true about it? has to be the diameter, and that has to be 90. Has to be at a 90-degree angle. Oh, crap. Yeah. Oh, we're not gonna get through it all.
Yeah.
Again, we've covered everything you need to know for the quiz. I was just gonna do some review. I totally forgot about this. I'm glad you said that. All right, so put all your stuff up, all you need calculator. This is one, have them do one, I'm sorry, 243. No, have them do 5 and try to give them space. There you go, Gordon.
I got super one.
So that's wrong, the 18. Didn't take you very long, so got plenty of time. So show all your work. I don't think I wrote on there. Make sure you show your work. You need to see everything you do. Show your work, show your work, show your work, show your work. Show your work. Done. Two. Wow. You know if he ever does that. You must be super confident. You're assuming somebody could do this. You're all done. Why did you like it? You see this again. This is ridiculous. Stall. All right, see that you're gonna see that again. And assume that things are the same size. Two. Don't forget about your deadline tomorrow, by the way. Deadline. You. Oh. Oh. Pardon? The questions are in it? You. You. But again, this is from that same section. I told you it's gonna be a little bit closer. You gotta practice those problems for exit ticket day. What I give you two? About these outside. Tutoring after school, if you can make, well, I mean, tutoring also lunchtimes, like second lunch, but after school is one of the few times I'm doing that, so.
Okay. I think it looks like that.
Because I realized if you over it, like the bottom of it.
Did I put your grade in?
Um,
How are you gonna retake it?
because I know I did that. You don't have to tell me. I know I did.
Well, then I'm not grading the other one. If you wanna come in and just take it, then it's fine.
Okay.
Although. Cause you know me too.
No, just on that one, or just on that one week. I know how to do.
Yeah, cause if you know you did bad on it, then
I know I
that's.
do. No, I know I messed up on one part, that one part at the bottom. And I know how to do it now because my notes.
Miss again.
What is it?
Hold on. I don't wanna show my face right now.
Show your face. I wanna see. Show your face. Somebody, what did she say? Something about you yesterday, Ksenia.
So can we take it?
So they keep saying that you're talking about the freaking, the great granola bar thingy.
Yeah, that's what, yeah. I had her take a picture of something else. Well, she took a picture of me, but I don't know how it is. Like you. She said one day, she said one day something about you, doing something. I forget what she said you had done. All right, girl. So if you come in at lunch, we can go over it and then I'll let you take it tomorrow.
Take it tomorrow.
Yeah. Yeah, because I'm not confident that you were good to go on this.
Okay.
Each has something. How have you been?
Allegedly.
What do you mean go back?
Mr. Gill.
Go back to the part.
I thought you lived in Tampa.
Yeah,
Yeah, but I moved back.
Oh, I didn't know that.
I did the first or third time.
That's a good one. I love stranger things. Question mark. Yeah, so why'd you move to Tampa? Because of stuff? Yeah, I
What?
two of them.
Oh, he does.
I gotta walk the other one. You want to get, what, dirty or?
I don't care. I
You know
just
what?
need it at some point. Make sure you get it to me. I'll write down that you turned in one. I got a list somewhere. I'll write down that you turned in one. Where are you at?
House.
So here in Canal, like you're permanently back in Canal Park right now.
Just say yours.
Oh, wow, I didn't know that. Ksenia did not mention that at all.
Maybe it's not so.
She tells me all kind of things. She tells me all kind of things about you, and she didn't mention that.
I don't know.
Yeah.
It's not so familiar, but it's just not.
She reminds me a lot of you. She reminds me a lot of you. Do you know why? You've had that conversation with you?
Actually, don't have.
Why she reminds you of you specifically in class? How she turns into, well, hopefully not, but hopefully she's not high too like you, but yeah, she draws little flowers. I said, hopefully she doesn't. I don't know. Your hair looks short. Oh, that's what I think she said, that you cut your hair really short. I think
It's
that's.
cute when it's cute. I don't know what's.
So you're saying it's not cute right now? Is that what you just said about it? You said you.
Yeah, she is giving.
Why did you cut it then? You didn't want it short.
No, it's cute, sure.
Oh, you know, I would have cut it for you.
Yeah, you really did that in class.
That's what I was just talking about. Do you have to
I
get?
cut the piece of my hair and I just cut it at night and then I had to get it next day.
That's too funny. That sounds about right.
It's cute.
So everything's good though?
Yeah.
Yeah, that didn't sound super convincing. You know, I miss you, girl. You hear me? You hear me?
No.
I said, you know, I miss you, girl, right?
Oh my God. I think you do. I think going to.
You saw her everybody.
Oh, that's super cute.
Yeah, it is cute.
Are you singing? Are you singing in the video?
I don't know what she's
It
doing.
looks like she's singing in there. She was playing the bro, little bro.
Okay.
You?
Go to class farm.
All right, girl, you be good. Take care of yourself.
What's that?
Um,
What's that? Oh yeah, you remember Shawn White? She said I'm mean. Okay. Why you keep doing that?
That one to you. That was somebody else.
You're the
Oh, big old PCAC today, huh, Bo? I do. What's that?
There might not be a bucket.
There was something.
Because they've been.
Oh, yeah, tennis said they don't get buses. Like, that they won't give them a bus. I don't think it's true. I just think Miss Miller doesn't want to take a bus. He's telling that they should.
But why-
take a bus.
It's
It's just-
They stopped here. They're looking for weeks. Or
You didn't just use a school bus through the. Oh. That's not weird.
they've been looking for weeks for a bus, and then like, before practicing, they said there was bus. Now there might not be one.
So you got like.
It used to
last
be
minute rain?
movie. Well, I don't know if they can one, so.
I feel like I actually have.
Just you.
I have to see.
Really.
Is it where like they go back into the 50s, like it's modern time? Like,
Yeah, it's a Spirit Week thing.
I could not get through much of it, but I did
It's
watch
so
it
good.
for a
It's so
little
good.
while. Yeah. I know it. You have your exit ticket today? I gotta go. Oh, I didn't stop the recording. I know, hold on. Or somebody else will get it. Somebody nice. Ah.